Hello. Hello, am I audible to all? Hello.
Okay,
Okay.
okay.
Can I start now? Hello. Okay, let's start now. I'm sharing my screen now. Is my screen visible to all?
Yeah,
Hello.
yes, yes.
Okay, let's start.
Yes.
Uh, so, for the hacker study, you have need two important files. First, the projection files, and second, the DEM file. These files are important for the simulation of HEC-RAS 2D. You can download the projection file from spatialreference.org website, and you can download the DEM file from the Woven site using the satellite Cartosat and other radar which will you need. So a projection file it depends on the your particular river, which river you choose. On the basis of you search on Google which UTM zone is required for this, then you can search on spatialreference.org website and can download that projection file. So first let's start from the projection setup. This is step 1. So for projection setup, first you require to create a folder of your project name. So go to file, go to new project, and here you will give your project name. Let's say I name practice. Okay. First of all, you choose which particular folder you want to save your project. So I name my project now practice. Then okay. And then if here you change your unit system. Here default US system is US customary, but you have to choose system international metric system. Here you choose this one, then okay. Then here yes. Then after that open the RAS mapper. This sign is RAS mapper sign. So open RAS mapper. Then you have to set projection first. First step is you have to create a folder of your project name. Then give the go to new project, select the folder, give project title, then okay. Second step you have to go to RAS mapper. Then RAS mapper, after you RAS mapper set projection. This is very basic to for the simulation of HEC-RAS 2D. Here this is the projection file. Go to folder where you download the projection file from the website. Your automatic saved in your folder. From here the projection file is in the form of .prj. So when you download the file, this will be shown like this. So choose the projection file from your folder, then open. Here projection file is selected now, then go to OK. Then after the projection setup, then add terrain. Go to terrain, create a new RAS terrain. Here you go to plus sign, then after go to terrain file. The terrain file will be in the TIF form. So from here choose the terrain, then open, then create. So now you see this is the terrain file as my river is this is the terrain file of Brahmani river. I have a terrain file of Brahmani river. So this is a Brahmani river. This is the Kharshua branch, and this is the Brahmani branch, which is located in Odisha. So from here you can set up your add map layer. Here is the map layer. Add wave imaginary. Go to Google Map, Google Satellite. So you can see the Google Satellite, but your terrain file is not visible. So for this, you have to uh, change the opacity. Now this is visible to all. My DM file is this, and this is all Google Satellite, which is now overlapped with the Google Satellite. It is visible to you all, na? Hello. Okay, then let's move forward. Then after that, you have to go to geometry. From here, first of all, you save the file, then go to geometry now.
Further processing no sir. Okay, okay, now come.
Okay. Now, after all the things you have done in RAS mapper, now you have to go to the geometry. Then in geometry, as there is Google, not Google Satellite, Google Satellite is not shown here, so you have to add the Google Satellite. From this sign is the sign of Google Satellite map layer. Here it is visible to you all. So tick the Google Satellite, then close. You can see the Google Satellite here. So after uh, this geometry, then you have to add 2D flow area. मतलब which flow area you wanted to your simulation part. So go to 2D flow area. Here you can edit the flow area, which area you want to simulate in your HEC-RAS. So start from upstream to downstream. Always start from the upstream. Then after that you go to downstream. So I start from here. And here you carefully close the enclosed area. Okay, yeah. Now name the river. I named the Brahmi. Then okay. Here the area part I enclose in my river, which means कौन सा एरिया आप लेना चाहते हो पूरे को आप enclose कर दो. Then after that, then assign Manning coefficient. So for assigning Manning coefficient, go to edit. This is tool part. From using tool part, you can edit the area part, and using editor part, you can assign the Mannings. Here from in tools, you can 2D flow area, and in editor also you can see 2D flow area. But using the tools 2D flow area, you can make the area part of the river, which area you want to show. And using the editor part into the flow area, you can assign the mesh and the Manning's value. So let's see, for a particular river you can see your what is the Manning's value, and in my case, okay, I use 0.121. Okay, 0.0127. and from here generate computation point. You can add means how much cell size you want in x direction and also in y direction. So I choose in x 70 and also in y 70. Means where smaller the cell size gives more accuracy, but it also have increase your computation time. So it's like hit and trial method. Here I choose the 70 and 70 and generate points in 2D area. So you can see that for this total area, my maze contains now 1924 cells. Then okay, here here you can see the grid cells, which is total 1924 cells, and this is of size 70 and 70. Then after creating maze, then please save your geometry data, give your geometry name, in my case practice dot geometry practice geometry, then okay. Then after saving the geometry, let's verify in RAS mapper is this mesh appear in my RAS mapper or not, or if this 2D flow area is visible or not. So save geometry data, then close this window, go to RAS mapper. You can see the mesh we draw in our geometry is now visible in this RAS mapper. So it means the confirmed geometry is correctly recreated. It's if your geometry is not visible in RAS mapper after you create in the geometry, then it means your 2D flow area is not correctly created. Uh, it is visible now. So it means geometry is correctly created. Now from here, save. We'll close this window. Go to geometry. Then in after save geometry, now you have to give boundary condition. Okay. ठीक है. Go to boundary condition line from tools and start from upward. Here, double click. At last, you have to double click from your mouse and give the boundary condition. As this is upstream, so I give the name here upstream. Then okay. And such that you have, in my case, I have two downstream. So first, if this is Kharsua branch downstream and this is Brahmani branch downstream. So let's draw the boundary condition of these two branch. Let's say downstream 1 and go to boundary condition line. And let's say it is downstream 2. Then you can my boundary condition are now set. I have give the name. It is my upstream and it the two branches downstream 1 and downstream 2. So after that, save the geometry now. Close the window. Then go to for your boundary condition. Go to edit. And in my case, I've used the discharge data on a steady flow. So I go to unsteady flow data. So here you can see the boundary condition line. In my Brahmani river, there is one upstream and two downstream. For the upstream, I use the flow hydrograph. I will use the flow hydrograph. In flow hydrograph, you see the date and simulation time. The date is depends on your discharge data, which or of your particular river. Here you can fill the flow of your particular river on the basis of it is editable. You can edit on the basis of flow data. I can show you. I have my already prepared data for this. So in upstream, you have to always choose flow hydrograph. Means upstream you have to give discharge data, and in downstream 1 and downstream 2, in both case you have to choose normal depth. Normal depth, it is frictional slope. Frictional slope you can find out for your particular river, or you can search of which frictional slope is best for your particular river. So in my case, I in Kharshwa and Brahmani part, I used 0.006. Like I've tried on many frictional slope, but it is like hit and trial method in my case. You can choose your type. Then okay. Then in downstream 2, you have to also choose normal depth. So please carefully see that in upstream you have to choose in unsteady flow condition. I told about unsteady flow condition. This is totally about unsteady flow condition. In unsteady flow condition for upstream, you have to always choose flow hydrograph. In flow hydrograph, you have to give the discharge data. And in downstream case, you have to give the normal depth. Normal depth, it is like frictional slope. So after that, say on a steady flow data, after you give the flow hydrograph. So from here, already have 1 month of data prepared for Brahmani River. So I will use this data set for further demonstration. From here, I use my already prepared data set because it takes much time. So this is my Brahmani 1 month run, already prepared data set. So start from where I stop. So in upstream, you have to choose flow hydrograph. In my in my Brahmani case, I have data of flow. So you can see I have data from 1989 to 1990. It's all data. And you can feel the flow in the here, and you have to use which part you want to simulate. So from here, fix start time from where your flow start. In my case, I give the my start time 1 January 1990, and the time is 00. You can also give the time 2400. You can try. And as I have data of 1 day interval, so here I choose. You have many options here. You can choose which interval data you have. So I have 1 day interval data. So here I choose the 1 day, and fixed start time means part you want to simulate. From where, which date you want to simulate. I want to simulate from 1 January. So I give choose the here. You can choose the date from here. You can choose any date from here, and you can give the time on which part you want to simulate. Then okay, and normal depth in my case, I choose the 0.008. from in Brahmi downstream, and in Kharswa downstream I choose the 0.006. Then okay. Then after that you must please save the unstudy flow data. Then after you save the unstudy flow data, then before running the data, this is the last step. Your major step is to give the boundary condition. This is major step in any simulation. You have to give the boundary condition, and for boundary condition you have flow hydrograph data. This is major part in HEC-RAS 2D. So after that, the last step is running the simulation. Before running the data, go to RAS mapper. Here in 2D flow area, here you see compute 2D flow area hydraulic table. From here, you have to compute the 2D flow area. Before running the simulation, you have to compute the 2D flow area. From here, you can see that this is process is successfully done. Then after that, save the RAS mapper, then close this window, then go to running. This is the sign of run the simulation, and you can also go from here, run and study flow analysis. From here I have my already prepared data, so don't have to give the plan name, but you start from very new project, so from here you have to give your plan name, and geometry file is already visible as you have already saved the geometry file title. So tick mark all the without sediment, because I don't want sediment in my simulation. So check marks all geometry preprocessor, unstudy fluid simulation, post processor, and flood plain mapping. Uncheck this one and check this one. Start date from your flow hydrograph data. See there which start date your simulation can start, and a starting time. In my case, my flow hydrograph data, its starting time is 31 December 1989, and ending date, you can also see this from your flow hydrograph table, and also ending time. Computa sorry, computation interval, you can see on the, you can computation interval take mainly, you can, it is also like a hit and trial method. You can start from 1 minute, 2 minute, 5 minute on the basis of your data. I have a total 1 month data, so I took the 15 minute, because it will take more time if my computation interval is so small. So from here it already default 1 hour, but you can also change. But uh, I मैंने इसे ऐसे ही छोड़ दिया 1 hour 1 hour 1 hour. Then after that, last step is you have to compute. So here you can see the simulation start. So as it is all blue means it gives a successful simulation now, and my overall accounting here you can see here. So it is like a hit and trial method. You means आप एक बार में ही इसे मतलब सही कर सकते हो, सही नहीं भी कर सकते हो, तो you can change computation interval here. You can change computation interval, you can change normal depth, and on the basis of this you can simulate your successfully simulation, and then close this window. For the simulation is successfully done, you can see from here in RAS mapper. So after your simulation, this is the result part. This result part is shown when you complete your simulation. So in complete simulation, as I have planned 01, this is all the result I have got after the simulation. This is depth. You can see the depth variation, like how river flow. I say you can see this is depth variation of the river, and you can see any point depth variation. Click on any point which where you want to see the depth variation. So I want to see in the upstream. Right click from your mouse at this point. Go to mapping time series. Go to depth. Here you can see the plot, and here also you can see the table. So table, this is variation at upstream point. You can see that 1 January 1990 starting time, there is the depth is very negligible, 0, and as you can see the variation of depth 10 January 1990 at this time, you can see the depth here, and also you can see 30 January 1990 at this time. This is the all depth variation. You can also see the velocity variation. So this is velocity variation. Hello. So you can also see the velocity table from here. Click on any point from your mouse and go to velocity and go to table. This is also in meter per second your velocity table. So you can see the depth, you can see the velocity, and also you can check from profile and longitudinal variation. This is Brahmani profile line. From here you can see the longitudinal variation of velocity in the Brahmani part, and this is the table. And for you can draw you can draw profile line from here. Here you can see the pencil. So using this you can draw the profile line, and you can save the profile line. So that's all in this part. So save the window and close, and from here you can see the flow hydrograph. This is the sign of flow hydrograph with elevation, time and depth, and this is flow. With flow, this time and this elevation. You can see the hydrograph of upstream, and you can also see the Kurzweil flow hydrograph shown like this. You can see in which time interval how much flow in Kurzweil part. This is flow, this is time, and you can see the Kurzweil on, and also you can see the Brahmani part in which time how much flow. So close the window. So overall, you can check the velocity, depth profile, and hydrograph from using this and you can also see many other things. So this is the complete. This completes the workflow of HEC-RAS study for study flow. Please try this on your data set. From my side. Hello. Hello. So let's conclude our
Okay,
session now.
thank you.
Okay. Thank you.